A stream of data. Amanda DelVecchia and her lab measure greenhouse gas emissions from local streams to uncover how they impact our warming planet. By Emmy Trivette. August 20th, 2024. A truck dappled by morning light carries a gaggle of students down a rough road alongside New Hope Creek in Durham. They bump and thump, elbow to elbow, while the truck maneuvers across rocks, roots, and small potholes. The sound of mourning doves and distant stream trickles pour through the cracked windows. This is an average start to a field day with the UNC Chapel Hill Freshwater Ecology and Biogeochemistry Lab, managed by Geography and Environment Professor Amanda DelVecchia. The lab focuses on the interconnectivity of environmental factors, from stream temperature to oxygen in the water to the bugs that live amidst it all within freshwater environments. Their current study, called the Macrogas Project, questions how different stream characteristics affect how much greenhouse gas is produced or released into the atmosphere from watersheds. Understanding the variation between different habitats in their greenhouse gas generating processes in streams is difficult because it requires so many measurements and variables, DelVecchia says. These variables include how rapidly the stream moves, how much oxygen is present, temperature, pressure, and the actual amount of greenhouse gas present in dissolved form. Research in the DelVecchia lab uses data from the National Ecological Observatory Network. This National Science Foundation effort connects 28 freshwater sites nationwide, which pool their data to better understand how freshwater ecosystems in the U.S. change, especially since their habitats emit 69 million metric tons of carbon into the atmosphere annually, or 70 million individual plane tickets from New York to Paris, DelVecchia says. 3 sections comprise a stream: riffles, runs, and pools. Water in the riffle section quickly flows over small, shallow, rocky areas. Runs are fast and deep, and the pools are stagnant water. The riffle acts like a chimney, DelVecchia says. Measuring the gases that are pushed out is important. We normally don't do that. Recent data from the lab suggests the highest concentrations of carbon dioxide are associated with warm, gentle slope streams, like the ones often found in the Piedmont region of North Carolina. But right now, the measurements taken in those streams have limitations. The lab focuses on areas with heavy gas release, and their methods involve taking one measurement in an accessible and deep part of the stream. But this assumes that one point represents an entire section of the water body. DelVecchia recognizes there might be better approaches. The more they do it, the more data and experience they will get, and the more she hopes to refine current methods to fill the gap in biogeochemical research. These variables are of interest because they affect how the stream breathes and its energy, DelVecchia says. Pooling knowledge. Each fall, winter, and spring, DelVecchia's team of students and postdoctoral researchers capture a variety of measurements, from water speed to temperature. They install 9 different sensors at the start and end of each pool in New Hope Creek to uncover how much carbon dioxide and oxygen releases into the atmosphere. To do this, they use a homemade gas chamber that captures gases on top of the water and provides real-time data for emissions. Constructed using PVC pipe, a plastic sampling bag, and a bit of mechanical engineering, the chamber isolates gases coming off the water and provides an estimate of greenhouse gas flux. This tool is managed by Nguyen Tien An Guoc, known by the team as An, a first-year PhD student in DelVecchia's lab. At first, everything was so new, Guoc says. I did not know what I was doing, just tagged along to learn about the methods, but I knew they would be useful for my project. Guac's previous work focuses on how insects interact with freshwater ecosystems. While he didn't have a gas background going into the macro gas project, he's now a leader in the lab thanks to DelVecchia's guidance, and will soon begin fieldwork for his PhD project to understand if and how freshwater macroinvertebrates contribute to greenhouse gas emissions. She wants all her students to understand how these processes work, Guac says. If you don't get it, or if she's going too fast or too slow, she will adapt to your learning ability. DelVecchia prioritizes her lab as a learning space. She offers a first-year seminar that includes optional fieldwork for students who want the experience. Many students are excited to get out there to collect samples and see the connections of what we're doing in class, DelVecchia says. I've always loved fieldwork so much, since my first summer in college. I feel very at home with these processes around me. Amanda DelVecchia is an assistant professor in the Department of Geography and Environment within the UNC College of Arts and Sciences. Nguyen Tien An Guac is a PhD student in the Department of Geography and Environment within the UNC College of Arts and Sciences.